we're going to be labeling the measure of angles, central angles of the unit circle, angles in standard position, both in degrees and radians. And in this video, we're going to restrict our angle measure between 0 and 360 degrees, 1 revolution around the circle, or in radians, theta, our angle will be between 0 and 2 pi. So I've highlighted some of the common angles in the unit circle. And to begin with, I've denoted 0 degrees here along the positive x-axis. If we imagine one ray of an angle lying on this positive x-axis and a second ray coinciding, just laying on top, the angle formed by those two rays would be 0 degrees. Now if we took and rotated the terminal side of the angle until it corresponded with the positive y-axis, we can see that we've rotated that angle 90 degrees. The axes are perpendicular. And so here at the top of the circle, I've labeled positive 90 degrees in rotation. We're going to move counterclockwise around the circle. That's the positive direction of rotation. At least that's what we agree upon. Okay, so if we move another 90 degrees around the circle, we're on the horizontal axis, and we can label that 180 degrees of rotation. Going 90 more, we're down here at what I call the South Pole. That'd be 270 degrees of rotation. And if we took this initial side and rotated it all the way around the circle once, that would be an additional 90 degrees, and we could label this coterminal angle as 360 degrees of rotation. Now we're going to look at the bisectors of the quadrants. Again, the quadrantal angles were 0 degrees, 90, 180, 270 down here, and 360, which is coterminal with 0. So 4 quadrantal angles labeled on the axes. Now if we take half of 90 degrees, that should bisect this first quadrantal angle, and half of 90 would be 45. And in the second quadrant, if we were to bisect that quadrant, we would add 45 degrees to 90 and label that bisector, that amount of rotation is 135 degrees. Similarly, if we go 45 degrees past horizontal and we're in the third quadrant, that's 225 degrees. And notice if you add 45, you're down here at 270. And if we go 45 degrees past that vertical, we're at 315 degrees, bisecting the quadrantal angle in the fourth quadrant. Okay. So typically, one would go back and label the trisectors of each quadrant, and we would have all the common angles in one revolution of the circle. Okay. So trisecting 90 degrees, we take 1/3 of 90, and that's going to be a 30-degree rotation. So again, if we have our rays affixed at the center of the circle, and we rotate the terminal side 1/3 of the way through the quadrant, we're at 30 degrees. If we go an additional 30 degrees rotation, we've got a 60-degree angle, and another 30 degrees, we're up there at 90 degrees. Okay. So we really just want to go back through the unit circle and label every additional 30-degree angle. 0 to 30, 30 to 60, 60 to 90, 90 to 120. We'll add 30. We have a 150-degree angle in the second quadrant. Add 30 more, we're at our quadrantal angle. Add 30 more, we're at 210, then 240. We've already labeled 270. Coming around in the fourth quadrant, 300 degrees, 330, and then finally adding 30, we're back to where we started, and 0 degrees is coterminal with 360. So in black, I've labeled common angle measures in the unit circle in degrees. And now I'm going to go back and pull out a red pen because I want us to label those same angles in radians. Recall that 100 degrees is equivalent to pi radians. And so if we took half of that, 90 degrees would be equivalent to pi over 2 radians. Okay, and we might as well get our, let's take half of that again to remind ourselves that every 45 degrees of rotation can be considered pi over 4 radians of rotation. And then 30 degrees, or 1/6 of 180, would be pi over 6. Okay. So in red, our quadrantal angles initially would have 0 radians. Then moving around a quarter of the way, we would label pi over 2 at the North Pole, 2 pi over 2, or just pi, at the East Pole, or is that West? West Pole. And then 3 pi over 2 down south, and adding another pi over 2, we would be at 4 pi over 2, or equivalently 2 pi. Okay, so our quadrantal angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now dividing each quadrant in half. So if we rotate halfway through the quadrant, that's half of pi over 2, or pi over 4. An additional pi over 4 would be 2 pi over 4. Simplified, it's already labeled. Another pi over 4 would bring us to 3 pi over 4 in the third quadrant. An additional pi over 4 would be 4 pi over 4, or simplified as pi. Then we move to 5 pi over 4 in the third quadrant. 6 pi over 4 is already labeled and simplified. 7 pi over 4 here in the fourth quadrant. And then 8 pi over 4 right here, already simplified as 2 pi. Okay. So we've bisected all the quadrantal angles, and we notice that every angle in radians, if it's not simplified, would have a, well, all of the fractions would have a denominator of 4, 2, or maybe a denominator of 1 if it's been simplified. Okay. And to finish out our circle, labeling in radians, a 30-degree angle, 30 degrees trisects that quadrant, will be labeled as multiples of pi over 6. All right. So our first central angle, where we rotate the equivalent of 30 degrees, is labeled pi over 6. That second trisector would be 2 pi over 6, and 2 pi over 6 would simplify to pi over 3. 3 pi over 6 is already labeled and simplified. 4 pi over 6 will simplify to 2 pi over 3. And at any time you can pause and make sure that the black degree angle matches the red radian angle. A person can take degrees and multiply, let's see, by pi over 180. The degrees cancel, and you can simplify and verify that my red label is correct. So we've been labeling in multiples of pi over 6. Pi over 6, 2 pi over 6 reduces. 3 pi over 6 reduces to pi over 2. 4 pi over 6, then 5 pi over 6 has not been labeled. 6 pi over 6 would reduce. 7 pi over 6, 8 pi over 6, but I want to simplify that. And 9 pi over 6 will reduce to this quadrantal angle. 10 pi over 6, 11 pi over 6, and 12 pi over 6 gets us all the way back around to 2 pi.